More with APIs. So far, we have learned what APIs are, how to import them into our programs, and how to know if they are accessible. Now let's learn how to retrieve their data so that we can use, display, or store it. There are two commands that will allow you to use or print information from an API: content and text. There's really only one difference between the two commands. Content returns the response in bytes, text returns the response in Unicode. The most common use of each is that if we want to use or print text, then we use the text command. If we want to use or print an image or PDF, then use content. But either command can be used at any time based on the preference of the programmer. Let's go back to our dog API program. This time, instead of printing whether we can access the API, use the content command to print an image of a random dog. The output is below. We receive an image of a husky. Note, when you run your program, a different image with a different breed will appear as the search is random. Modify the content call to text as shown and run the program. Notice the slight differences in symbols in the file between using the content and text calls. This is because the file is now in Unicode instead of bytes. What if we wanted to search for a particular breed of dog? We can do this by modifying the URL. To do this, adjust the breeds in the URL to breed/Labrador to search for images of Labradors, and let's go back to using content since we're searching for images. What happened when you ran your code? The following displayed: error, breed not found. Code 404. This API appears to not contain Labradors in its master list of dog images, and therefore an error message displayed. This is a great example of how spelling counts in programming. The dog breed is spelled Labrador, not Laboradors, and therefore may still exist in the API when spelled correctly. Try it to find out. Now let's search for hounds instead. We located a random image of a hound. So here we now have the URL for a picture of a hound. Note, again, this may be a different type of hound than your search will return when you run this program, because this is random. Instead of looking for dog images, let's locate a list of dog breeds available in the API. We will go back to using text, since we're looking for a list, not an image. So here we have a requests get, we have the dog.ceo/API, and we end it with list/all. To do this, adjust the original URL to this new one here and run your program. The following displays a list of all the dog breeds in the API, and the list continues. How did we know how to modify the URLs to target our searches? While many modifications are straightforward when using APIs, a programmer cannot know them all. Because of this, it is critical to use the API's documentation when working with it. The documentation provides you, the programmer, with information on how to modify a URL and add specific parameters to narrow your search when looking for content within an API. Our dog API documentation is located online if you would like to further work with it in your program. Let's try another example. We will write a program that checks whether the iTunes API is accessible and then performs a search for Mariah Carey. We will then take it one step further and store our search results into a file. We'll use the iTunes Search API documentation to be sure we're modifying our search parameters correctly. First step, use the documentation to determine the URL for the iTunes API and print status code to determine if a connection is possible. So here we have our base URL. We want to print the data.statuscode, and look, we get 200. The output of the 2 here indicates we've established a connection and can search the iTunes store. Now change the URL to search for Mariah Carey. To do this, look at the documentation. A question mark in the URL is one way to indicate a call to parameters in this API. Then the phrase term equals is used, followed by what information is being searched, separating words with a plus sign. So here we have our base URL, then a question mark, term equals Mariah plus Carey. So remember, look in the documentation to see the format that this URL should be in. When we search Mariah Carey on the iTunes API, this is some of what we find. There's a lot of stuff. Then there's more. This search is too large for us to look at all at once. What if we want to save it for review or use later on? Our Replit IDE has a way to create a file for the data. To create a file, store it to a variable using the command open. So here is going to be the name of the file being created. Here is the operation to occur on the file, which will be explained on the next slide. And we're going to save that into the variable file. The operation will be one of 5 main abbreviations. R reads the contents of a file. W writes in the file, or overwrites if data already exists. A appends onto files, so add on to existing data in a file. WB writes binary in the file, and RB reads binary from the file. As we're looking to write the data from the API to the file, either W or WB are appropriate operations here. Finally, we need a command that indicates what data to write in the file now that it has been created. Using the write command, we can take the information pulled from the API, data.txt, and write it into the file we created to store the data. Let's add our new commands to the program. The file, called mariah.txt, now holds the information found when we searched Mariah Carey in the iTunes API. We can now access this information at any time and use it in our programs.